Okie dokie. We're going to be on page 8 of the Unit 7 packet. And we are going to continue solving inequalities. Today we're going to focus on multiplication and division. And then we're going to practice writing an inequality and solving them. All right, let's start with this one. So again, this is going to look very similar to what we did in equations, just that we're going to have an inequality sign. So we're going to rewrite it. This says 4x is greater than 24. So this is 4 times x. So I'm going to do my little wall here. To get rid of that times 4, we're going to divide by 4 on both sides using the fraction bar. So what happens is the 4's cancel out, and you get x, keep the symbol, is greater than 6. So for this to be true, x would have to be greater than 6. So let's pick a number greater than 6, 10. 4 times 10 is 40. 40 is greater than 24. So that seems reasonable. I think that would make sense. All right, and again, no check because there's an infinite number of answers. We don't want to check an infinite number of numbers. We just don't have time. We just don't have time for that, or space. Let's check this one. X divided by 6 is greater than 5. Do a little bar here, the wall. How are we going to get rid of divide by 6? I have an idea. Let's multiply by 6 on this side, and we'll multiply by 6 on the other side. So we're just doing the inverse. Those 6's cancel out, and we're left with x. That's greater than again. X is greater than 5 times 6 is 30. So let's check a number greater than 30 that you can divide by 6. Let's check, I don't know, it's 36. 36 divided by 6 is 6, and 6 is greater than 5. That works for me. That works for me. All right, let's try this. Similar type of problem here. We have 5x less than or equal to 45. So for these, we're going to solve it, and then we're going to graph it. We'll do our wall. How do we get rid of times 5? Well, believe it or not, we're going to divide by 5 on both sides. The 5 and the 5, they're gone, and we're left with x. Let's keep the symbol, less than or equal to 45 divided by 5 is 9. So x has to be less than or equal to 9. Let's check to see if, 3. 3 is less than 9. 5 times 3 is 15. 15 is less than or equal to 45. That works. All right, let's graph these solutions. X has to be, it can be anything less than or equal to 9. So we'll start at 9. We're going to do a closed dot because 9 is included. Closed dot. Less than or equal to 9. So we're going to go less than. The less than direction. There it is. Oh, yeah. Okay. Next. Let's try this one. Again, similar idea. We're going to solve it. We're going to check it. Well, actually, no. We're going to solve it. We're going to graph it. All right. So x divided by 8 is greater than 3. We want to get the x by itself. So we want to do the opposite or the inverse of divide by 8. And that's going to be multiply by 8. We're going to do that to both sides. So I'll put my wall there. Multiply by 8. Okay, let's see what happens. The 8's cancel out. And we're left with x is greater than 3 times 8. It's 24. Let me check. Let's say a number greater than 24 that you can divide by 8. Let's check 32. 32 divided by 8 is 4. 4 is greater than 3. That checks out. X would have to be greater than 24. Now, let's think about our graph here. Excuse me. Would 24 count? X has to be greater than 24. No, 24 would not count. It's not greater or equal. It's just greater. So we're going to have an open dot. X has to be greater than 24, so we're going to go in the direction of the greater numbers. I'm just going to make this line a little thicker here. A little darker. All right, that showed up okay. Going to have our arrowhead going in that direction. We want the numbers greater than 24, but not including 24. All right, if you want to try these two on your own, you can. Let's see how they go. Here we go. 10 times x is less than, that's the one that looks like an L, less than 80. Do our wall. How are we going to get rid of that 10? 10 times x, what's the opposite of the inverse of 10 times? It's going to be divide by 10. And we're not just going to do it on one side. We're doing it to both. 10 and 10, those cancel out. X is less than, keep the symbol, x is less than 80 divided by 10 would be 8. Okay, would be 8. So already I'm thinking it's going to be an open dot. X has to be less than 8, but not including 8. So it's going to start at 8, but not include 8. It's a pretty good open dot right there. And then we want x is less than 8. Notice I keep going back and checking the solution. I keep reading it to myself because it reminds me of how to make the graph. We're going to have all the values of x that are less than 8. That line went a little haywire right here, but it's pretty good. It's pretty good. Okay, the last one on this page, you can try it on your own. You can do it with me. Let's see. It's up to you. X divided by 6 greater than or equal to 7. Okay, so I'm going to put the wall, make the wall. We have an x divided by 6. We want to get rid of that divide by 6. So we're going to multiply both sides by 6. These 6's cancel out. And we get x is greater than or equal to, what's 7 times 6? Would be 42. So x has to be greater than 42. Let's check 42. 42 divided by 6 is 7, and 7 is greater than or equal to 7, so that would work. So we're thinking our dot. What's our dot going to be? It's going to be at 42. Is it going to be open or closed? X is greater than or equal to 42. That's going to be closed because we're going to include 42 because it's or equal to. X is greater than or equal to 42. We're going to go greater, and there it would be. Ta-da! Look like that. All right, let's go to the back. So we just tried multiplication and division. Again, they should look similar to the ones we did with equations. Let's check out these two. So what we're going to do is we're going to write and solve a couple of ones on our own. And at the bottom, we're going to practice solving each one of the different types of inequalities. Laverne is making bags of party favors for each of the 7 friends attending her birthday party. She does not want to spend more than $42 on the party favors. Write and solve an inequality to find the maximum cost of each party favor bag. So what are we trying to find? It says find the maximum cost of each party favor bag. So our let statement is just going to be cost of each party favor bag. Now, here's the cost of one. It's going to be C. Well, how many of those is she going to get? It's not just the one. She's not going to just buy one party favor bag unless she's having only one guest to the party. But it appears on closer inspection that she's not having one guest. She's having 7 people over. So the cost of all the party favor bags would be 7 times the cost of each bag. Like if each bag was $2, we do 7 times 2, which is 14. That's times 7 will tell us we're buying 7 of those bags. Now, she does not want to spend more than 42, so we're comparing this to 42. She may not spend more than 42. She can spend 42, but not more than that. She can spend less than 42 or 42, but not more. So I'm thinking this is going to be less than or equal to. Remember, the less than symbol looks like an L. So I'm going to draw the one that looks more like an L, but I'm going to add the or equal to sign because she can also spend exactly 42 bucks. All right, so now we can solve it. So we're going to do our wall. We want to get rid of that times 7. So we're going to divide by 7. Divide both sides by 7. Excuse me. 7's cancel out. C needs to be less than or equal to 42 divided by 7 would be 6. So each party favor bag needs to be less than or equal to $6. So it's asking us to find the maximum cost. What's the most she could spend? Less than or equal to 6? It seems like 6 would be the most because she could spend less than 6 or she can spend 6. 6 seems to be the maximum amount. So Laverne can spend, at most $6 per bag, per favor. That's almost close to the Spanish for please, por favor. Per favor would be what we're writing. Okay? So that was a little tricky. There's not going to be one like this on the quiz coming up, but it's good to practice this. So we're just writing, it's almost like a one-step inequality here to solve that. And this one below it is also similar in some ways. It says Tino's Pizza charges $9 for a cheese pizza. Depending on the size, it's not bad. Eileen has $45 to buy pizza for the Spanish Club. Write and solve an inequality to find the maximum number of pizzas that Eileen can buy. So we'll start with our let statement. I'm going to go with P for pizza. P equal number of pizzas Eileen, which is my grandmother's name, Eileen can buy. Okay. Well, if she was buying just one pizza, it would just be P by itself. However, or if the pizza was $1 even, we would just have P by itself. These pizzas are $9. $9 for a pizza. So that's the number of pizzas that she's going to get. To find the total cost of all the pizzas, you could multiply the number of pizzas she's going to buy by 9. That will give you the cost of the pizzas. Now that cost we have to compare to the number 45. Well, let's see. Is that the most or the least she can spend? That would be odd if they told her the least you could spend on these pizzas is $45. It says write and solve an inequality to find the, again, it's the maximum number, the most. So she can spend, or the maximum number of pizzas. She can spend $45, but not more. She can spend less, but not more. She can spend less than $45 or equal to. So it's kind of similar to the last one in some ways. So to solve this, do our wall. We want to get the P by itself. We want to find what's the maximum of the most number of pizzas that she could buy. We'll divide both sides by 9 to get rid of that times 9. Those 9's cancel out. You get P is less than or equal to 45 divided by 9. It's 5. So it says write and solve an inequality to find the maximum number of pizzas that she could buy. All right, just had a special guest just walk in. Just had to talk to them for a moment. All right. So Eileen can buy at most 5 pizzas. She can't buy more. She can buy less, certainly. She can buy 1 if she wanted to, but she's got $45 to spend. You might as well get the 5. All right. Now, the ones below here, these are going to be kind of quick because we're just going to do one of each. Again, if you want to try these on your own, that might be a good idea, and then check with me. If you want to kind of mute the video maybe and just do them on your own and just check with your with the answers when you're done, that's fine. But we're going to solve and check these. So we'll start with V minus 2 is greater than 6. Let's do our little wall here. We want to undo the minus 2. So we're going to add 2 to both sides. Plus 2 plus 2. 2's cancel out. V has to be, keep the symbol, greater than 6 plus 2, which is 8. V has to be greater than 8. It can't be 8. It's got to be greater than 8. So we're going to have an open dot. V has to be greater than 8. We're going to go in the greater direction. Greater. Perfect. Okay. Let's try this one next to it. 9 plus F is less than or equal to, oh, I heard that graphite snap. It's probably going to come out. Oh, there it goes. All right. Do our wall. Less than or equal to 14. 9 plus F is less than or equal to 14. We've got to get rid of that plus 9. So let's subtract 9 from both sides. 9 minus 9, believe it or not, cancels out. And you're left with F is less than or equal to 14 minus 9 equals 5. So let's think about that for a moment. F has to be less than or equal to 5. So it can be 5 because it's got the or equal to. So we're going to use a closed dot, less than or equal to 5. So we're going to go in the less than direction. Less than. Sorry, my line's a little ragged, but I had to write it like that in some ways. Okay, all right, let's try. Let's try the next one here. So again, you can try these on your own, but you can also kind of do them with me if you're still feeling unsure. 6 times x has to be less than 30. Let's see what would work for x. Okay. The wall. How do we get rid of that? Times 6? Well, we're going to do the inverse. We're going to divide by 6 on both sides. 6 divided by 6, gone. Cancels out. X, keep the symbol, is less than 30 divided by 6 would be 5. X has to be less than 5. It can't be 5. It's got to be less than 5. So because it's just less than, open circle, open dot, and we're going to go less than 5. So we're going to go in the less direction. Going this way. Going this way. Nice. Make sure you get that arrowhead on there. Show the direction. And then it goes on forever and ever and ever. All right, last but not least. We got y divided by 2 is greater than or equal to 3. Okay. Y divided by 2 is greater than or equal to 3. So wall, how do we get rid of that divide by 2? We're going to multiply by 2. Times 2 on this side and on the other side. 2's cancel out. We get y has to be greater than or equal to 3 times 2 is 6. Y has to be greater than or equal to 6. All right. So it can be equal to 6. It's a greater than or equal to. So we're going to have a closed dot. Greater than 6 or equal to. So we're going to go greater. Arrowhead. All right. That was just a little practice with inequalities of all the different operations. If you have any questions, let me know. If not, have a great day, and I'll see you soon. Bye-bye.